Hello students, welcome to the third lecture on the lecture series on fourth lecture on the lecture series on permutation and combination. Okay, so in this lecture we'll actually do some more exercise problems. In the previous lecture we did a variety of exercise problems, so that all the concepts that you actually learned on the lecture where I taught permutation and on the lecture I taught combination. Okay, so basically I taught permutation in the first lecture and combination in the second lecture, and what we did was in the last lecture we did some mixed problems where permutation and combination were what heavily used. Okay, so in this lecture also we'll do some more advanced problems where actually permutation and combinations are used, so that all the kind of concepts and property that these two hold and how they are actually different, that actually matters, you'll learn in this lecture. Okay, while doing all these exercise problems. So let's start and do some more exercise problems. So let's start from the problem number 1. So all the letters of the word what EAM caught are arranged in different possible ways. Okay, so the number of such arrangements in which no two vowels are adjacent to each other is what? Okay, so let's try to see how many letters are there. 1, 2, 3, 4, 5, 6. So basically there are 6 letters, right? So what we want to know is the number of arrangements in which no two vowels are adjacent to each other. Okay, so let's try to actually see how many vowels are there. So A, E, I, O, U. These are the 5 vowels, right? So among these, A is here and E is here, and I, no, it is not here. O is here, right? So only 3 possible vowels are there in this word. Okay, so actually let's try to see in how many ways this whole thing can be arranged. So this can be arranged in what? 6 factorial ways, because there are 6 letters there. So 6 total ways, right? So let's try to see if always 2 vowels are there. Okay, 2 vowels are, if they are always together, then how many possible ways are there to construct that kind of word. Okay, so first you have to choose 2 vowels from the 3. Okay, so it can be actually done in what? 3C2 ways. That is equal to what? 3 factorial by 2 factorial into 1 factorial, right? It will be 3 ways are there. Okay, for choosing what? 2 among from these 3. Okay, so 6 factorial are total ways, and 3 in 3 ways actually I can choose 2 from these 3 options. Okay, so let's then assume that 2 as 1. Okay, so how many letters will be there? So there will be 5 letters remaining after choosing those 2 to be 1. Okay, so 5 factorial ways are there to what? So 5 factorial ways are there to construct that word. Okay, so it will be what? 5 factorial into 3. Okay, and total we have what? 6 factorial ways. So subtracting that from this, because in this always 2 vowels are together. Okay, at least. So by subtracting this, what we are left with is all the cases where no vowels are together. So this is what? 6 factorial into, so basically 6 into 5 factorial, 6 into 5 factorial minus 3 into 5 factorial. So it will be 3 into 5 factorial. So this much amount of ways are there. Okay, where no two vowels are actually adjacent to each other. Okay, so let's go forward and see the problem number 2. Okay, so 10 different letters of alphabet are given. Okay, so words with 5 letters are formed from these given letters. So 10 different letters of alphabet are given. So let it be actually A, B, C, D, E, F, G, H, I. Okay, A, B, C, D, E, F, G, H, I, and J. Okay, the 10 different alphabets are given. So words with 5 letters are formed from these given letters. So then the number of words which have at least one letter repeated is what? Okay, so this seems to be a tricky question, but it is actually not that tricky. All you have to do is you have to deform this question into small subparts and then solve it together. Okay, so constructing a 5-letter word with the possibility of repeating letters, there are actually 10 to the power 5 possibilities. Okay, because for all the 5 letters there are actually 10 options are there. So 1, 2, 3, 4, 5, 6, 4, 5. There are 5 positions. For this you have 10 options. For this you have 10 options. For this you have 10. For this you have 10. For this you have 10. So all have 10 options, right? So that is how there are actually 10 to the power 5 possibility. So however, using 5 distinct letters, there are actually 10p5 ways. So you must be wondering why we use permutation, because here there is distinct letters, and actually the order matters because we are talking about words, right? It is not a committee or a class representative, where actual order doesn't matter. So in this part, order actually matters, okay, in this concept. Okay, so let's try to see how to actually determine the desired number of words. Okay, so total possible is this much, and in this much way there will be distinct. So in all the possible ways, for 69,760, there will be at least one letter that will be actually repeated. Okay, so problem number 3. So the number of signals that can be sent by 6 flags of different colors taking one or more at a time is what? Okay, so basically the number of signals that can be actually sent by 5 flags. So the correct answer will be what? 1956. How? Because the number of signals using one flag will be 6p1, that is equal to 6 ways are there. So number of signals that can be used using 2 flags is what? 30. Okay, so using 2 flags we can actually give 30 signals. So number of signals using 3 flags is what? 6p3, that is equal to 120. So number of signals using 4 flags is what? 6p4, that is equal to 360. So number of signals using 5 flags is what? 6p5, that is equal to 720. Number of signals using all the 6 flags will be 7p6, that will be 720. So the total number of ways is 1956, summing all these things up. Okay, so let's try to see problem number 4. So in an examination there are actually 3 multiple choice questions. Okay, so each question has 4 choices. Okay, so there are 3 multiple choice questions and each question has 4 choices. So number of ways in which a student can fail to get all answer correct. Okay, so when can he get all the answers but correct is when, let's see in how many ways he can actually attend all those questions. Okay, so basically for each question he has 4 ways, 4 options. For this he have 4, for this he have 4. So total 4 into 4 into 4, that is equal to 1664 ways are there to attend these 3 questions. Okay, but let's say only one is correct among these, but 4, only one is correct among these 4 and only one is correct among these 4. So let's try to see if he gets, okay, what we want to. So here order matters, right? So what happens is, let's try to see how can actually we denote but a question which can actually be correct, then we subtract it from the whole thing, and then what we'll get is that much amount of but questions that where the student can fail to get all the answer correct. Okay, from the combination only one set of answer is correct, so the number of ways student can answer the correctly is 64 minus 1, that is equal to 63 ways. Okay, so the straight lines L1, L2 and L3 are parallel and lie in the same plane. Okay, the total number of m points taken on L1, n points on L2 and k points on L3. The maximum number of triangles formed with vertices at these points are what? So here it will be the total number of points, that is m plus n plus k, which must give what? M plus n plus k, see 3 number of triangles. Okay, it will be a very large number of triangles if m, n and k are actually greater than 2 or 3. So m points on L1 and taking 3 points at a time gives what? MC3, and similarly NC3 and KC3 for what? The other planes. So number of triangles cannot be formed. Okay, therefore the required number of triangle is this much minus this much minus this much minus this much. Okay, so let's go forward with problem number 6. So find the number of different 8 letter arrangements that can be actually made from the letters of the word daughter. Okay, 1 2 3 4 5 6 7 8 letters are there, right? So that all vowels occur together, that is all vowels do not occur together. Okay, so given that the word daughter, there are actually 8 unique letters including 3 vowels, that is A, U, E. Okay, so if we consider these vowels as one entity, that is A, U, E, so they must be grouped together, right? So then among all these 5 other letters, okay, we have 6 entities in total. Okay, so arrangements of these 6 entities taken all together, so 6p6 ways are there. Okay, that is actually 6 factorial. So using the multiplication rule, what we can see is there are actually 6 factorial into 3 factorial ways. Okay, that is equal to 4320 ways, possible ways. So let's see the case where all vowels do not actually occur together. So to determine those permutations where all the vowels aren't grouped together, we first look at the possible arrangements of 8 letters, okay, which is 8 factorial. Then from this we subtract the arrangements where the vowels are actually together. So we can do that. We have already evaluated that part. So what we are left with is 50 with multiplied with 720. Okay, whatever it is, it will be the actually correct answer. Here is the correct answer. So how we evaluated this? So thus the desired permutation will be total arrangements minus arrangements with vowel together. Then we'll get arrangements without any vowels together. Okay. So let's try to see problem number 7. Okay. So in how many ways can 4 red, 3 yellow and 2 green discs be arranged in a row if the discs of the same color are indistinguishable? So 4 plus 3 plus 2. So it will be 7. So 9 factorial by 4 factorial into 3 factorial into 2 factorial. So it will be actually whatever the value is, it will be the correct answer. Okay. So it will be 9 factorial by 4 factorial into 3 factorial into 2 factorial. That will be actually 20, 12, 60. Okay. So total number of discs are what? 9. That is how we have written 9 factorial in the numerator. Okay. So find the number of arrangements of the letters of the word independence. In how many of these arrangements do the letters start with P and all the vowels occur together? Okay. Do vowels never occur together? Okay. Do the words begin with I and end with P? Okay. So let's try to see the word independence. Okay. So I is repeated only once. It is actually it occurs only once. N is N about N is actually repeated thrice. That is it occurs thrice. And D, so D happens twice. Okay. E happens 1, 2, 3, 4. E happens 4 times. Okay. So for C there is none. So C occurs only once. Okay. So total number will be 1 plus 3, that is equal to 4, 5, 6, then 10, 11. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So let's try to see what we have missed. So N is thrice, D is twice, 1, 2, and E is 4 times, 1, 2, 3, 4, and C is only once. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 are there, right? So 3 plus 2 is equal to 5, 9, and then 10, then 11. Okay. But here we have 12 numbers are there. Okay. So I believe we are missing something right here. So I is 1, right? N is 1, 2, and 3. N is 3. And D is twice. Okay. And E is 4 times, right? And P is there. Yeah. P is missing. P is what we are missing. So P is occurring once. Okay. So basically there are actually 12 letters, right? So do the words start with P. So P has only one choice. So start with P. So the remaining options are what? 11 options. Okay. So among these 11s, there will be what? 11 factorial by 3 factorial into 2 factorial into 4 factorial. Okay. This much will be the answer of part I. And for part II, okay, do all the vowels always occur together. Okay. So the number of vowels, it will be equal to what? 1, 2, 3, 4, and 5. Okay. So if we consider this 5 as 1, okay. So if we actually consider this 5 as but 1 factorial, so 1 entity. So what we are left with is, so 5 to 1. Okay. So what we do is 12 minus 5. Okay. So it will be what? Added, then 12 minus 5 is equal to what? So it will be 7, right? 7 plus 1 is equal to, so then we add with 1. So it will be 8. Okay. So since this will be 8, so there are actually what? 8 factorial ways. Okay. So 8 factorial ways. And then what we do is, we actually have how many ways can these vowels be arranged among themselves? Because E has been repeating 4 times inside that. So it will be what? 5 factorial by 4 factorial. Okay. That is equal to 8 factorial into 5 will be the answer for part II. Okay. So if we try to figure out for the answer for the part III. So do the vowels never occur together. Okay. So here all the vowels occur together. So let's try to have a scene where actually 2 vowels occur together. Okay. So in order to have 2 vowels together, so E and I must come together, right? So let's try to have E and I together. So let's consider these 2 as 1. So we have now what? 11 letters are there. Okay. So only 3 E's are there. So there will be 11 factorial by 3 factorial because 3 e will be always there. So into 2 factorial. Then n are 3 times repeated, so it will be 3 factorial, right? So this many way we can actually arrange those 11 letters. Okay, then multiply with what? 2 factorial, because e and I can be actually among themselves in 2 factorial ways. So this will be the answer for part 3. And let's see for the part 4 what will be the correct answer. So do all the vowels? Actually no, this won't be the answer. Okay, so the full answer will be what? 12 factorial minus this much, because it asked us that do the vowels never occur together, and here we have assumed they occur together. Okay, so all the remaining cases will be the case where vowels never actually occur together. So do the words begin with I and end with P. Okay, so let's try to see. I is here, P is here. So all the remaining parts are what? 10 numbers are there. So 10 letters are there. So it will be 10 factorial by 3 factorial, 2 factorial, and 4 factorial. Okay, because these are the repeating ones. Okay, so 4, 2, and 1. Okay, it will be this much. So let's go forward to the next question. Okay, so a committee. Okay, so by hearing the word committee, you must be wondering what should come to your mind. Should permutation come into your mind? Combination. Actually, combination will always come. Why? Because order actually doesn't matter in terms of forming a committee of 3 persons. Okay, so a committee of 3 persons is to be constituted, right, from a group of 2 men and 3 women. Okay, so there are basically 2 men are there and 3 women are there. So in how many ways can this be done? So how many ways this committee would be consist of 1 woman and 2 women? Okay, so therefore, so what we need to do is, so basically 2 men are there and 3 women are there. Okay, so what kind of combinations can be there? Either the committee must be what? So consist of 1 woman and 2 women, right? So in how many ways can this be done? Okay, so first try to see that in how many ways can we form a committee. So from 3 and 2, so we want to form a committee of 3 person where 5 persons are there, that is 2 men and 3 women. So it will be 5C3. Okay, this many total ways. Okay, we can actually form a committee. Okay, in how many ways the committee would consist of 1 man? So it will be 1 choice. So 2 choice into 3 choice into 2 choice. It will be 4 into 3 is equal to 12 choice will be there to form a committee using what? 1 man and 2 women. Okay, so this will be the answer for that part. So let's try to see the 10th kind of problem. So what is the number of ways of choosing 4 cards from a pack of 52 playing cards? Okay, in how many of these 4 cards are of the same suit? Okay, 4 cards belong to the 4 different suits. Okay, are actually face cards, and 2 are red and 2 are black cards. Okay, so cards are of the same color. Okay, so basically what we have is we have 52 playing cards. Okay, so let's try to figure out the case number 1 where 4 cards are of the same suit. Okay, so it will be what? So it will be, so what we want to consider is we want to pick 4 cards. Okay, so from, so how many ways are there to pick 4 cards? Okay, so it will be 52C4, right? This is, in this way we can actually pick 4 cards of the out of those 52 cards. Okay, but if we want to pick actually 4 cards of the same suit, okay, so how many ways can we pick a suit? So it will be what? 4C1, because there are 4 suits. So to pick one, it will be this much choice. Okay, then to choose what? Out of those 14 cards, to choose 4 cards. Okay, 13. Okay, it will be 13C4, because we have choose a suit and then we need to choose what? 4 out of those 13. Okay, this many choices. So this will be the answer for pick. So let's try to figure out the question number 2. So 4 cards belong to the 4 different suits. Okay, so what we need to consider here is, for the first card you need to choose what? 13C1 choice are there, and for the second there are 13C1, and for the third it will be 13C1, and for the fourth it will be 13C1. Multiplying all those, so it will be 13C1 power 4. Okay, this many possible ways are there for part 2. Part 3, that is, are face cards. Okay, face cards are what? Only one choice is there for the face card, right? So we want to choose 4 cards, so it will be the same here. Okay, to choose face card, it will be actually 13C1. It will be actually only one way is there, only one way actually. Okay, because you are choosing actually the face cards. Okay, there is no other way. So 2 cards are red cards and 2 cards are black cards. As you know that there are actually 26 red and 26 black cards are there. So how we can choose actually 2 red cards? So it will be 26C2. And how we can actually choose 2 black cards is 26C2. So multiplying these two, that is 26 square, is the answer for IB. Okay, so let's try to see the answer for part 5. So cards are of the same color. Okay, so basically all the cards are of the same color. Okay, so it will be what? First we have two choices, either black or red, right? So it will be C, 2C1 into, then what? 26C1, then 25C2, or then it will actually have 26 choices, then 25, then 24, and then 23. So this will be the answer for part 5. Okay, so these are all the 5 options that can be actually 5 questions that have actually been solved. Okay, as you can see here, solving these actually doesn't need much of an effort. Okay, if you see all those things clearly that we have already learned, right? So these are basically 22, at most it is actually 30-second question. Okay, if you think clearly and with good confidence. Okay, so at first when you saw these questions, okay, this seemed to be very hard, right? Very complex. But as you solve this using the fundamental techniques, okay, by breaking down, okay, these questions, so you can actually solve this question in very less time. Okay, so I believe we have done sufficient amount of questions for this class. Okay, so in the next class we'll actually start some previous year questions. Okay, so that all you could get is some better boosted confidence, and actually you gain more knowledge out of those questions. Okay, so thank you, and we'll be learning previous year questions in the next lecture. Okay, so thank you.